into the ring with Joe Reis, data's black belt, 2 decades deep, where data's toughest fights are felt. A recovering scientist, mastering each form, breaking silos down, setting new norms, from engineering strikes to machine learning kicks. He mastered mixed model arts to blend and to fix. With wisdom and grit, he guides us today. In the dojo of data, he's leading the way.
Okay, let me reset my stopwatch. Okay. So I'm Joe. I'm going to talk about mixed model arts, the convergence of data modeling across apps, analytics, and machine learning, and AI. So, motivations for this talk. So last year, I traveled the globe giving a talk called Data Modeling is Dead, Long Live Data Modeling. I think it went really well. I was invited to speak at a lot of places about it. But overwhelmingly, this talk was about I think revisiting the notions of data modeling. Who does data modeling? Who thinks they do it really well? Okay, that's what I thought. Okay, so this notion really was, I think we need to revisit data modeling from first principles, and I think also recognize where the world is going, which we'll talk more about in a bit. But anyway, talk about data modeling. So why now? Why talk about data modeling? This has been a topic that's you'd think has been mature, has been around for a long time. By the way, how's my cadence, my flow? Good? Slower? Good? Okay, great. Who's heard of AI? Right, so this means data is getting a second look. I would say until ChatGPT, if you talked about data to companies, most companies would say that's cool. We're not going to invest in making our data better. We just want data. I'll talk more about this in a bit. Who feels like their data sets are amazing? Which you all data model, right? Which is interesting. You all know about it. So that's fascinating. We'll talk more about this. So the interesting thing is, as an industry, there's a lot of money and attention on data that we didn't have before, right? I think what I'm hearing from a lot of my friends in the industry and what I'm seeing personally is companies want to take data seriously. This may be the first time I've seen this happen. Things like data quality, governance, and modeling, right? And so my question is, with all this money and attention on data today, if we're not going to take things seriously, like quality, modeling, and so forth, then when are we ever going to do it? Right? Every time I go on LinkedIn, there's somebody complaining about how we need to add more value from data and other stuff. And I feel like this is the perfect time to do it, because it is. So a lot of companies are still trying to solve data problems with AI, right? This is the theme from last year. And I feel like we're getting better at this, but have we solved everything? Did it get magically fixed? Of course not, right? This is actually still one of the big what's the word, crux? Is that a word in French? It's the hard part, right? We want to do AI today, but if you want to, who would put a large language model on top of their corporate data sets today? Raise your hand. One half person. And one other half person, so it's like one person. Right. And I have asked this question around the world and probably from tens of thousands of people. Nobody's raised their hand and said, yes, I will do that. Because my other part of the question is, would you risk your job over this? If you, I know you can't get fired in France, so it doesn't matter. But so yeah, you'd be like, yeah, I'll do it all day. But in the U.S., you could get fired, like for anything. But also, why now, right? I think that in data modeling, we're focused on a handful of tabular modeling techniques. Hannes mentioned tables. Tables are awesome. But we still fixate, especially in analytics, on things like Kimball, dimensional modeling. Ralph Kimball came up with a dimensional model in 1996. Bill Inman came up with the data warehouse in 1989, right? And we still go back to these old techniques. Not to say they're not great, but the world has moved on, right? You have streaming, you have data science, you have machine learning, AI. But I still feel like we're still stuck in the past. I mean, see the other one, COD. with a relational model that came out in 1970, right? In 1969, 1970. And so I think the question is now, like, what are we doing to keep up? And I can answer, like, right now, not much. With streaming data or NoSQL data, Hannes mentioned Mongo. I actually think I have Mongo socks on because I'm poor. So if any vendors have new socks, let me know. I'll take them. These will be eventually consistent. That's a joke. So the question is, data sets are still a mess, and I think we need a new way of thinking about of data. I think that the technology has surpassed where the methods and the standards are for data modeling right now. So as an aside, I grew up in the 1980s. I grew up doing combat sports, boxing, wrestling, all that kind of stuff. I still practice jujitsu once in a while. But when I was a child, right, being naive, it was always a question with me and my friends, would the Karate Kid beat Mike Tyson in a fight? Or would Bruce Lee beat Hulk Hogan or somebody like this in an actual fight? And back then, it was all about being one-dimensional in your fighting style. Mike Tyson, who now is like 100 years old and fought last week and lost, took a dive, I think. But the whole notion of one-dimensional thinking is very much like how we've been thinking about data modeling, right? We think about one technique that will do everything. Again, dimensional modeling is great, data vault's great, but we need new ways of thinking about data. I equate this to mixed martial arts, actually, which is who follows mixed martial arts or knows what it is, like UFC, right? So in this case, if you were to take a one-dimensional combat athlete and put them into the UFC, say a really good boxer, but they only know boxing, what do you think is going to happen? Yeah, they'll get destroyed, right? Having done MMA, I can tell you that it requires a lot of things: how to fight standing up, on the ground, in the cage, when somebody's on top of you. But I think this is very much like data right now. The convergence I'm going to talk about is of applications, analytics, machine learning, across multiple data types, right? It's not just a world of tables anymore. You have images, text, video, all this other stuff, metadata, all these other things that we're trying to incorporate into models. And so we need a new way, basically a new style of working with data, right? Again, the one-dimensional style isn't enough, just like mixed martial arts now really showed the way of what true martial arts could look like. If you started fusing together all the different techniques of jiu-jitsu, Muay Thai, kickboxing, Western boxing, wrestling, and so forth, and karate. So what we'll discuss: what's a data model, what went wrong, what's happening in the mixed model arts. So what's a data model? And I'm short on time, so I'll just give you the definition I have in my new book. A data model organizes and standardizes data in a precise structured representation to enable and guide human and machine behavior, inform decision-making, and facilitate actions. So notice what this discusses, right? We're talking about an approach that's agnostic to any particular modeling approach, right? It encompasses everything. We're very inclusive. We encompasses all use cases for data, and it includes AI and machine learning use cases, which if you look through different definitions of data modeling, it somehow leaves out machine learning and AI, even though this is the stuff that powers a lot of the modern world and will continue doing so. So what went wrong? A couple things. Data modeling is seen as too slow, too costly, old and outdated, and it doesn't matter. Who's heard these criticisms before, right? That it's, we don't need it anymore. I've had very prominent people in the industry tell me data modeling is not actually a thing at all. So I thought that was interesting. We're stuck in the past, right? This is Uncle Rico from Napoleon Dynamite. He dreams about the time he was a high school football player back in the 1800s or something. But this is the world he's stuck in, and I feel like data is very much stuck in the past. Data is only in tables. Tables are great, but there's all this other stuff, right? If you look around you, how many cameras do you see? 1, 2, I'm just looking at this room right now. 3, 4, 5, right? So data is not only in tables, it's in a lot of other things. And the same as it ever was, right? If you look back at why data projects fail, we're talking about reasons about, there's always this 80% number thrown out that 80% of projects fail, right? Who's heard these things, and it's always about something or other, usually about organizations or data, right? And poor data quality is at the top of the list for why a lot of projects fail. At the same time, we have every reason not to model data. Who feels like they have to do things very quickly in their jobs? Who feels like they have no time to think? You're just doing, right? Data modeling is very much a thinking person's activity, but at the same time, we're cramming this workflow into sprints, 2-week sprints. And these are almost diametrically opposed forces. Thinking doesn't work in 2-week buckets, right? Sometimes you need to think outside the box. But again, quality suffers as a result. I'm going to talk about the quality paradox. One thing I would like you to think about is if you could slow down just a bit and focus on doing things and increasing your quality, this will actually increase your productivity and speed things up because you have fewer errors. But right now, according to the informal poll I did, people have a lot of dirty data and so forth. Do you ever think you're going to get ahead of your problem at work? No, I'm seeing a lot of... So, but one way you could do this is by focusing on, again, the first principles, focusing on good data modeling, making sure your data is good. Whether or not you have the time to realistically get there, I don't know. Talk to your boss. They're also probably moving too fast for their own good. This is the nature. And if you think it's bad in Europe, go to America. We move about 1 million times faster there, and I would say it's a hellscape. So what's happening? So these are 2 data engineers, about age 25. They just came out of university. These are data. This is the data they work with. These are probably a pile of tickets they have to get to at some point. And who can relate to this image? Yeah, especially Hannes. He's like, yeah, that's me. Yeah, there's I'm sure under the table there's like a dead cat that's been there for like 9 years or something. So, but it's just most data people, right? When I show this slide, people sort of laugh, but then they're like, yeah, that's me. I relate to this. And these are data teams I see all over the world. By the way, the clock is ticking. It says they have 3 minutes left. Is that true? No? Okay. If I do, I'll make it really quick. But the data landscape is way more complicated, right? So you have the challenges as before. 80% of projects fail. We're dealing with, the mess you just saw in the last slide. But then you have all these buzzwords that you're expected to keep track of now and do, right? You got to be making data products. You got to be making a data mesh. You have to be using open table formats and data lake houses because that's the cool thing to do. And now you have to be doing AI, and you have to be using agents. Who's seeing more of this stuff in their work? These requests for anything on this list here. It's a new menu, right? Real-time data and so forth. So the role of a data engineer in particular is becoming more complicated. Because now it's not just what you used to do, it's now we need to do AI. Now we need to do this. Now we need to put the data back into applications and so forth. This is reality. Challenges today with applications. I see a lot of relational databases. I see very few relational data models, which is insane. Who understands relational modeling? Of course, but not that many, right? But this is the method that came out in 1970 that actually spawned the relational database, right? But if you study it, it's still an eloquent data model. The whole point is to reduce redundancy and duplication in data, to provide a very pure way of structuring your tables. It's just set theory and first order predicate logic. It's math. And it works, but very few people use it. NoSQL databases like these, they turn into data swamps, right? No different than what we've seen with data lakes. Poor data models, right? If you have a poor data model in your application, what happens downstream is the poor data engineer, analytics, or even data scientists and machine learning engineers, they get what? Poor data, right. And then you all get to deal with it. I'm assuming you all being the people who are downstream. An example of some challenges in analytics. This is from DBT's State of Analytics Engineering, but the number one thing is poor data quality, right? And then you have other things, integrating data from various sources, ambiguous data ownership, documentation, and so forth. A lot of this can be traced back to poor data modeling. When I talk to people who practice a lot of DBT, they say that they're doing modeling, but when I ask them what they mean by that, they say, well, I'm building DBT models. These are not the same thing, right? DBT is terrific. I partner with them once in a while and stuff. But again, the confusion really is that we're modeling but you're not using a particular modeling approach. You're just jumbling SQL together. Here's another example off of Reddit. Denormalized table. My org uses 3 denormalized data tables with full outer join. This data set is directly used by 900 Tableau dashboards and has 600 columns. Who's seen this hellscape up here in their own work? Yeah. Analytics. So upstream data is a mess. Data modeling, depending where you work, it's either religion or it's completely forgotten. There's many sources of truth. So analytics is all over the place, right? And I heard from some people about self-serve analytics. Who does self-serve? Does anyone do self-serve analytics? Kind of? Yeah, okay. But this is the reality of a lot of things. Here's some challenges in AI. This is from the RAND Corporation. What I find fascinating about this is 97% of business leaders are fully willing to jump into AI right now, but only 14% responded that they're actually fully ready to integrate AI into the workplace. This should give you a lot of pause when you think about this and how it impacts your company, right? Or do you think you're ready? Who feels they're ready to do AI today? Whatever that means. Yeah, 1, 2, 3, 4. Okay, yeah, out of many. And so this is actually a very interesting survey you should read. The 80% number keeps popping up again in the second paragraph. But if you look at the survey and the results, big things are data sucks, pretty bad at most companies. It's not well modeled. The other part is lack of data engineers to actually implement the infrastructure needed to do production-ready AI. So I would urge you all to read it. I think it's called something like, just Google RAND survey, why AI projects fail in production. It came out on August 13th of this year. And again, what I see right now is a lack of understanding how machine learning actually works under the hood, right? The data that's feeding most machine models is still an absolute mess. And so you have garbage in and garbage out. We'll talk more about this in a bit. Also, training and inference, depending on the method you're using for machine learning, can be either very cheap or very expensive. If you're trying to make a foundation model on your own, I would say good luck even getting the hardware to do this unless you have a lot of money. But there's cheaper ways to do it. So mixed model arts, what is this, right? What I'm noticing around the world when I talk to practitioners and even in my own work is there seems to be a convergence now. Historically, there was basically the flow of application to analytics to machine learning. What I'm seeing now is increasingly applications, analytics, and machine learning are all flowing together. There's a feedback loop amongst all these different workflows. And what does this mean for you? It means a lot of things, actually. The working with data isn't just about working with data in one silo or another. I think increasingly, especially as we move towards data product delivery, using a more kind of a lean methodology in production, this being single piece workflow of delivering a data product. And what this necessitates are new ways of thinking about data and working with it. Am I over time? Oh, sorry. And it was interesting when I talked to people like Jim Akdagani who came up with data mesh. One of the things is, it's her belief, and I do agree, that if data mesh is to become a thing, it means actually these silos between applications, data teams, and machine learning, it breaks down. These all become the same team. This is the convergence. So cross-disciplinary data modeling, right? Applications, analytics, machine learning. Who understands machine learning? Who works with machine learning? A few people? Good. That's awesome. Again, data sets are changing too. I wouldn't say they're changing, there's just more of them you need to consider. There's obviously structured data, but there's also semi-structured, unstructured, which is images, text, video, etc. Metadata of various types. Also the artifacts from machine learning, right? You're talking models, embeddings and vectors and so forth. And graphs, right? Graphs are seeing a heyday. They sort of go in the cycle, the popular, unpopular. Now they're getting more popular again. But the different types of data, right? So kind of closing out, how to do mixed model arts. This is the punchline. I think you can split this into knowledge and practices and technology. As I was telling some people last night, I feel like we have a lot of terrific tools in the world right now. I don't think we have any shortage of great technologies, but I think our ability to really fully use these technologies is limited by our practices so far. I would say, when I speak around the world and meet practitioners, I feel like the knowledge of how to, work with data is probably down here, where the technology's potential and capabilities is up here. So I feel like, my mission is to help close this gap, which is why I'm writing a book on this topic right now. But what are some things that you could do with knowledge and skills? I think, first, learn the big ideas in data modeling, right? This starts actually not with a specific approach, but understand conceptual, logical, physical modeling. Conceptual, you do it sort of whether you are aware of it or not. You're thinking of how does data relate to each other? What are the entities I'm trying to describe? What are the relationships between these? Know the various approaches to data models and how to use them. And be vigilant about data modeling on your team. With applications, this means understand the relational model, especially if you're going to use a relational database. It's there for a reason. It works. It powers a lot of stuff. I would say a lot of cardinal sins that I see in my own practice are the result of people feeling like they have a better idea about how to do OLTP transactional modeling if they're using a relational database. I would say avoid this. You avoid a lot of side effects and update anomalies. For NoSQL and streaming, just understand how to model correctly. Don't do redundant stuff. Don't do something just because somebody said on YouTube that it's a good idea to do it. Do your homework. Understand what you're doing. Revisit old ideas. Unified model language, UML, domain-driven design, all very applicable still, especially when you're building applications. Analytics. Understand the ideas, the big ones, dimensional, data vault, one big table. These are sort of the core ideas of analytical modeling. Avoid religious adherence to one true way. What I often see are religious debates in data modeling about my technique is the best one. I'm not going to name names, but one of them might be in the middle of the techniques I described. Shift left and right. Understand what's happening upstream and downstream from you. Work with upstream producers to provide you with better data. A question came up at Big Data London. Does self-service kill data modeling, self-service analytics? What do you think? Somebody told me it did. I had to think about this for a second. I think it was like a millisecond. But no, it doesn't. In fact, I think if anything, more data modeling knowledge needs to be in place for self-service to work. Otherwise, you have anarchy. I think as well, what you're seeing more and more is AI is being used in business intelligence and analytics applications and practices. And finally, knowledge graphs. These are making a big comeback in the world of analytics. For machine learning, if machine learning is not your background, I would say learn it, right? Learn, if you're working with tabular data, learn feature engineering. Learn how to test, train, cross-validate your data, learn the techniques, random forests, XGBoost, et cetera, et cetera. I would say just make sure, understand what types of data work with what types of machine learning algorithms, right? Deep learning is great for certain things. I would say for tabular data, it wouldn't be my first choice. You need to understand, right, that, also what worked for images, what worked for text, and so forth. Data-centric AI is an interesting one. So this is Andrew Ng. Christoph talked about a course. It was Andrew and I did a data engineering course in Coursera. But the big idea he's been pushing is data-centric AI, which I think was one of the reasons we decided to do a course together. Data-centric AI means that no matter how much hardware, how sophisticated your algorithms are, if the underlying data is of poor quality and is not useful, none of the other stuff matters. It really doesn't. So you need to make sure your data is in tip-top shape, especially when you're talking about your existing your corporate data sets, which I think by all accounts maybe could be better. Technology. Today's approach is not sufficient. I feel like we're very siloed in our approaches with the tooling. As a result, we basically patch upstream issues. Right, in analytics, I think we're notorious for this. Right, when we talk about things like semantic layers, they only exist at the analytics layer. But what about patching the data upstream and fixing the root cause of the issues? This is something we need to consider. I think, and again, it all comes back to how do you model the data in the first place? This is empirically true. And I can't see my next point, but oh yes, of course. So what happens is your conceptual models get out of sync with your physical models. I think we need a more comprehensive way to work with data. Some intermediate fixes, right? We all have diagramming tools, ERDs and so forth. There's semantic layers, like I described. There's data sharing. There's knowledge graphs. So I think this these are great, but again, if we're not talking about end-to-end data, right? Again, you're patching issues along the way. And I think in today's world where things move very fast, feedback loops are quicker and quicker between applications, analytics, and machine learning. We need a different way of working with data. What do we need? I've been thinking a lot about this. Feel free to start working on any of these ideas if you'd like. Maybe you are. There needs to be an automation between the conceptual model and the underlying logical and physical model. This needs to happen end-to-end, and it needs to happen across different use cases and modes of data. This is something I've been writing about and starting to work on, actually. But again, you need a human in the loop to understand if the outputs and the inputs are correct or not. But it comes back to the knowledge. If you don't have the knowledge, how would you know, right? So this is the heart of mixed model arts from a technological angle. So that's mixed model arts. Yeah, and let me just close out with this quote from Bruce Lee, who I consider to be the founder of mixed martial arts, which was, take only what you need, or something, I can't read that. Use what works, and and bring what's uniquely yours to the table, right? This is, I think, something that hopefully all of you can benefit from. So anyway, thank you very much, and yeah, Ankler's next. So,
Step into the ring with Joe Reis, stay past black belt to decades deep, where data stuff is fights are felt, a recovering science.